Hello, today we're going to look at lesson 3.2, equations of parallel and perpendicular lines. We're going to open that up and take a look at what we've got going here. There's a bunch of videos here that you can use to help you along the way. I'm just going to go straight for the two assignments that we've got to cover, and we'll take it from there. So we have previously worked with the idea of parallel and perpendicular lines and how to recognize them from equations. Well, you know that two lines are parallel if they have the same slope. All right, that's the first thing that we want to identify first of all, is the same slope implies that we have parallel lines. Okay, to determine if we've got perpendicular lines, when we look at the slopes, we should see the opposite sign reciprocal, right? So the opposite, or the negative, if you like, the opposite sign reciprocal. So for those of you who are unfamiliar with these terms, right, the opposite sign reciprocal means that you've got, if it's positive, it's going to be negative. If it's negative, it's going to be positive. And the reciprocal means that the fraction is flipped over. So the numerator is now in the denominator is in the numerator. Okay, so you're just flipping it over. If you remember your fraction division rules in 6th grade, you learned about keep, change, flip. The idea there is that instead of dividing by fractions, you're multiplying by the reciprocal, right? So that you're flipping the fraction. That's what this is. Fraction flip. Okay, so the opposite sign reciprocal means that you've got perpendicular lines. All right, so let's take a look at what we've got right here. All right, so we've got two equations right here. They are not in slope-intercept form, so let's convert them to slope-intercept form so that we can read them in an easier manner. Okay, so 2y, this 4x plus 2y equals 10. Well, all we've got to do is subtract 4x from both sides, and that will give us 2y is equal to negative 4x plus 10. And of course, we still have to divide by that, divide by 2, and so y is equal to negative 2x plus 5, right? That's what we got going on here. There's our slope is, so m is negative 2, okay? All right, let's look at the second one that we've got going on here. The second one we've got going on right here is, well, first we've got to subtract the 4x from both sides. So subtracting 4x from both sides gives us negative 2y, and I hope you see what's going on already. Negative 2y is negative 4x minus 10. Okay, minus 10. All right, and now we've got to divide by negative 2y on both sides, so that's going to give us y is equal to, well, a negative divided by a negative is a positive, so that's positive 2x, right? And a negative divided by a negative is a positive, so we get plus 10 here as well. So we've got the same y-intercept, but we've got a different slope going on. So our slope here, m, is equal to positive 2, right? Now, initially you might see here, okay, opposite sign, maybe these are perpendicular, but they're not quite perpendicular. They're just opposite sign. They're not the reciprocal. Note that the reciprocal of the first one here, the opposite sign reciprocal of negative 2 is positive, is positive 1 over 2, right? And the opposite reciprocal here is equal to negative 1/2. And obviously, obviously that they're not the same. Okay, so your signs are different. Okay, so these are not parallel lines because they don't have the same slope. They're not perpendicular lines because they don't have the opposite sign reciprocal. They just have the opposite sign, not the reciprocal. Okay, the difference here between same line and distinct parallel lines is that the same line would have the same y-intercept, which this does, but not at all. So different slopes means that they do intersect. And so let's move on from there. Okay, we'll look at a couple more questions, right? So I am going to keep the cheat sheet right here for you. The idea here that we've got opposite sign reciprocals is perpendicular and the same slope is parallel. So let's take a look at these two equations right here. So the first equation that we have going on, again, not in slope-intercept form, but if we convert it to slope-intercept form, we'll see that this is, well, 3y is equal to negative x plus 5. That's the first thing. And then divide by 3 gives us y equals negative 1/3 x plus, or minus, should I say, because it's, sorry, plus 5 over 3. We're not changing any signs here. This is a positive 3. Okay, so the second one here is, again, subtract 4x from both sides. That's going to give us 12y equals negative 4x plus 20. And dividing by 12 on both sides gives us y equals, well, we'll keep this simple for now, negative 4 over 12, so we can see it, negative 4 over 12x plus 20 over 12. And we can, of course, simplify the slope. That's all we really care about here. So y is equal to negative 1/3 x plus, well, we'll leave 20 over 12. We don't care about that, okay? Or do we? We have the same slope, so we're looking at parallel lines at least, but they might be the same line. So let's look at this y-intercept here. Okay, so the y-intercept here, we're going to simplify the y-intercept. If we divide both these by 5, we'll note that we get 5 over 3 here, and we've got the same y-intercept as well, so we're looking at the same line. Okay, so you'll see a variety of situations going on here. They'll have some of them will have the same slope and not the same y-intercept, giving you just parallel lines. Some of them will have the same slope and the same y-intercept, giving you the same line. Some of them will have the opposite sign reciprocal, right? And I do want to see maybe one more to see if we get one with an opposite sign reciprocal, so that we can so we can see an example of that. Because the last one we saw was not opposite sign reciprocal, so we could not determine whether they were perpendicular. All right, let's look at what we got here. This here is a point slope form equation, all right? So if you're familiar with your Algebra 1, your point slope form equation, we had y minus y1 equals m times x minus x1. So we may not have to do anything with that right now. What we're going to try and do is we're going to try and convert this into point slope form so that we can match them up, all right? So what this tells us is we've got a slope. So our slope m is negative 1/3. Let's look at that first. Okay. And we're just concerned with the slope first of all, right? If we can manage to get somewhere with the slope, we don't have to look at the y-intercept. If we get the same y-intercept, if we get the same slope, then we'll have to look at that. But let's look at just the slope first of all. So the second one here, we have we have to rewrite this. This is 6y is equal to negative 2x plus 24, or dividing by 6. Right, and we see what's going on here. We got y equals, well, negative 2 over 6 is negative 1/3 x plus, well, plus 4. 6 times 4 is 24. Okay, so we've got the same slope here, right? So we're going to have one of these, right? And what we have here is we've got a point slope form equation. So a quick way to see if this matches up is we're going to plug in our y-intercept here and see if this equation is true. Rather than trying to convert this into slope-intercept form, a quicker way will be just plug in your y-intercept. Our y-intercept is 4 here. So let's do that. So we're going to check and see if well, the y value is 4. If 4 plus 6, we're going to find out and see is 4 plus 6 equal to negative 1/3 times 0 minus 15, right? So we just plugged in the point 0, 0, 4, which is our y-intercept that we've got here, right? Okay. So we're going to test this. So we've got 10. Is that equal to all of this? Well, negative 1/3 times negative 15. So negative 1/3 times negative 15. Well, negative times a negative. This is negative 15 over 3, right? And we can see negative 15 over 3 is positive 5, and we find that 10 is not equal to 5. And so these are not the same line. They are distinct parallel lines because the y-intercept is different, right, for these two lines. Okay, so the only thing we didn't quite see was the opposite sign reciprocal. We did see something similar to that. We saw opposite sign, but not reciprocal, and we explained it. So we'll move on to writing equations with parallel and perpendicular lines so that we can, so that this video is not too long. Okay. So writing equations of parallel and perpendicular lines, we're being asked to actually write equations of parallel and perpendicular lines. So here we'll actually see the opposite sign reciprocal at work as well, right? So we're just going to remind ourselves, first and foremost, is that again, same slope implies that the lines are parallel. Right, that's what we're looking for here. And opposite sign reciprocal is perpendicular. Okay, so those are the two things we've got to remind ourselves of. And again, if you're coming to this late, the reciprocal, right, is when you flip the fraction. So reciprocal means that you go from a over b to b over a, right? You flip the fraction over, okay? So the opposite sign means that you're going to change the sign. So what we're looking at totally is we change the sign on it. A over b goes to negative b over a, okay? All right, so let's see what we can do with this. Okay, so write an equation of a line that's parallel to x equals 8, parallel to this equation x equals 8, and passes through the point negative 3, negative 2. Well, let's visualize this for a second. This is the line x equals 8. This is a vertical line, right? This is a vertical line, x equals 8, okay? So notice that there's two distinct lines that are either x equals 8 and x equals something means that every value is going to be 8. So it looks something like this, where we have the x equals 8 here, but everywhere along the line here, we're crossing over the x-axis. So that there is the line x equals 8. But we're looking for a line that's parallel to that passes through the point negative 3, negative 2. Well, let's look at the value of negative 3. So we're looking at negative 3. So we're going, okay, negative 3 right there. And we want a line that's parallel to that, to x equals 8. And so it's going to be a vertical line. So hopefully you guessed it. Our line here must be x equals negative 3. All right. So that was a pretty straightforward one. Just looking at a vertical line. Of course, a horizontal line would be y equals, right? Y equals just some number, some constant. Okay. So that one was a pretty straightforward start to writing an equation, right? Let's look at another few. Okay, so looking at this one here, we have a slope. We have a slope intercept form of a line. Y equals -2/7 x plus 9 that passes through the point 4, -6. Now here's the thing: we've got ourselves a slope intercept form of a line here. Okay, so our slope intercept form of a line, m equals -2/7, right? That's what we've been given here. And for our second equation, we're given a point, right? This is our point, right? So given a point, it makes sense to write a point slope equation. So a point slope equation, right? It makes sense to use that, okay? So we've been given a slope intercept. Okay, just a reminder, that point that we've been given, if we were to put this in point slope form, would be 0, 9, with our slope intercept is 0, 9, right? That's what we've been given. And the best way to write this is a point slope equation because we've been given a point. Okay, let's examine further what we're looking for. We're looking for a perpendicular line, right? So this is a perpendicular line is means that we need an opposite sign reciprocal, right? So we need an opposite sign reciprocal, right? That's the one we need. So an opposite sign reciprocal of -2/7 is going to be +7/2. So the opposite sign reciprocal is +7/2. So m equals +7/2. Okay, point slope equation. A point slope equation is y minus y1 equals m times x minus x1, right? Everything we need we have right here. So let's start it out. We're going to go with y minus our y1, so that's going to be +6. Y plus 6 equals m, which is 7/2. That's our slope, times x minus x1, so the x minus 4. And this is a perfectly satisfactory equation. If you wanted to rewrite it as a slope intercept, you could, but we're just being asked to write an equation, not a slope intercept equation, right? So we've got y plus 6 equals 7/2 times x minus 4. And that's a point slope form equation of the line. All right. So being able to juggle between the two is definitely worth it. Okay. Let's look at another one. All right. So we had one that was parallel with one that was perpendicular. So notice that how, in particular, that we want to highlight the fact here that that we went with the opposite sign reciprocal because it was perpendicular. See how the sign changed from negative to positive, and the reciprocal was flipping it over to 7/2. Okay, let me clean things up a little bit here. Okay. So here we go again. We've been given a slope intercept form of the line. There's our slope intercept form and our slope m. Our slope m is 1/2. Well, what are we being asked for? We're being asked for a parallel line, right? We're being asked for a parallel line. And so our parallel line is going to go through the point 9, 6. So it makes sense, once again, because we're given a point, use the point slope, or sorry, the point slope form of the line. All right, we've been given slope intercept. Let's use the point slope because we have a point. And parallel means same slope. So let's go ahead and do that. So our point slope is going to be y minus y1 equals m times x. Y minus y1 equals m times x minus x1. That's our point slope form of the line. And so let's build it y minus y1. So that's y plus 6, right? Minus y1 equals m, same slope. So m is 1/2 times x minus x1 is x minus 9. and that's how we do that. All right, so we've seen, I think, everything that we're going to see here. So go ahead and work on those. Another thing to point out for today, as I am out today, is that of course, under the supervision of the sub, if you're in my classroom today, as opposed to being relegated to the cafeteria, if you're in my classroom today, feel free to take your remediation folders and work on them in class. Make sure that you leave them behind. I've left a load of notes up on the boards in the class, so you're welcome to use those notes as well. Have a good day, and I'll see you on Tuesday.